Okay, so today I'm going to talk about this new era in networking. This new era in networking to me is, maybe I shouldn't bring up old stories, my wife might kick me on this one, but when I was in graduate school, taking networking graduate class at Rice University, the papers that he made us read were these papers from USC and Stanford and Berkeley explaining why TCP was awful and showing the little workarounds that they could do to fix this inherent problem in TCP. Well, the next year the professor left. He went off to start the IPNG effort, which became IPv6. Okay, awesome. But this memory comes back to me of how bad TCP is, but hang on, it's 2024 and we're still using it. Oh, and by the way, we're still using IPv4 sometimes too, which is kind of weird. So Jim and some of the others might remember years ago at Samba XP, there was a networking consultant, PhD guy, and I were sitting after a conference like this, working while everybody's around us at the bar drinking, all the geeks drinking, and we're coding up the first IPv6 mount. But I sort of feel like we need to get to that point now of doing the first QUIC mount. We need to finish this talk and go with Paolo downstairs, right? And finish the first QUIC mount in Linux, because we're unusual in that we don't have a QUIC driver in kernel. Okay, so quick thing. I work for Microsoft. These are my opinions, not necessarily Microsoft's. I work on the Samba team. What I'm talking about here is use of QUIC and some experiments on QUIC and some observations about QUIC. I work in Azure Storage, but I work on Linux. Okay, what I'm going to talk about today is I'm going to review briefly. We have a status update from the lead developer on this project. There's at least 3 guys at Red Hat that have been working on this. One of them is the SCT maintainer. We'll discuss what changes would be needed for CIFS-KO or KSMD and what's coming soon, and some discussions about testing. So you could ask, why does QUIC matter? You could ask ChatGPT, what does it say? It reduces latency. Okay, agreed. Multiplexing, it allows you to, why is QUIC good? It allows you to multiplex multiple streams. You don't have that head of line blocking stuff. Connection migration, you can seamlessly migrate without disrupting the data transmission. Okay, that's great for mobile devices or certain other scenarios. So his point earlier that Homa guys said, well, for wide area networks, QUIC matters more. This reduced latency, great. Fewer round trips when you're setting up a connection, better congestion control, this is all good. ChatGPT may do a terrible job in trying to debug my bugs or maybe Paolo's bugs in the kernel. It's terrible about finding bugs in the kernel, but it's pretty good about stuff like this. So I would agree, actually. Now, what else? Improve security, okay? Using TLS 1.3, great. Robust encryption, adaptive congestion control, faster handshakes, much faster, fewer round trips with the 3-way handshake issues. And it's incredibly important, especially for short-lived connections, like you might see in some of this SMB stuff. And so their point, ChatGPT, I think was absolutely correct. By leveraging this, kernel protocols and things we do in the kernel, like SMB 3.1.1, maybe for block devices and NFS someday in the future exist, these kind of protocols can get significantly faster performance, better security, and more reliability on transfer. In modern, you get low latency, multiplexing, adaptive congestion control. So I actually agree with AI on that one, but unfortunately it misses the obvious. And this is a pretty big thing. For a lot of people, the only thing they care about is this idiocy of port 445 blocking. So I was amused at Spectrum at home. I can't save this presentation into the cloud. I can here at the hotel. I can inside, my son's house because they have a different internet provider. But some internet providers block 445 because of Ukrainian attacks 20 years ago, or hacks to the Iranian nuclear labs or whatever. I mean, these things that happened years ago with Landman 1 or something, right? So they see that over port 445, 20-year-old Windows systems did this or that, and they block it reflexively. So the fact that we do the strongest encryption possible, the fact that you're authenticating very strongly, the fact that you're doing the checks for man-in-the-middle attacks doesn't matter to them. So from my perspective, number one advantage is I don't have to worry if I'm at a conference. I could be presenting my slides using, what do they say, eating your own dog food? What we tried to do in the past, and we'd often do, is make sure that the presentations we saved were on a mount, let's say in Azure, or if you're a Samba developer in Samba, so you're showing that you're using your own code while you're giving your presentation. Well, we can't do that if 445 is blocked. So for me, that's a big one. Nobody's blocking 443, right? Because you're going to block everything. It also, another thing I like is the idea of mixing machine credentials, because typically a quick connection is for machine to machine. But you also have user credentials. So you log on to Active Directory, or you do OAuth, or you do peer-to-peer Kerberos. So the Mac example, so you've got your user identity, but you also have this machine credentials, so you get kind of double layer of security. And what about the thought of unencrypted mode? I was talking to the Microsoft QUIC developers. They took the Windows kernel QUIC driver, and it's now available and commonly used on some user space Linux things. But they had a test mode for unencrypted. Now, it was rejected by the standards committee, but the test mode allows them to run unencrypted, and they found it faster than TCP. And conversely, are there going to be cases where for security that maybe some days it's valuable to double encrypt, to encrypt with your machine credentials over QUIC, and then the SMB encryption with your user credentials on top of that? Maybe. But I think that those are some obvious kind of fun things to play around with. Now, what about alternatives? Okay, RDMA, fantastic. I don't know if you guys talked with the Chelsea IO people right outside, right? They're sitting right there. RDMA is fantastic. SMB Direct is heavily used in Windows. Long Lee, 4, 5, 6 years ago, added the support to Linux for RDMA for SMB, called SMB Direct. It's a mapping layer for RDMA. SMB is protocol agnostic. It can layer. I was at a conference years ago and worked with an HP developer, and we got SCTP working. It's no big deal, right? SMB doesn't care what protocol it runs on. It's not layered like Sun RPC is. So, we just sit on top of whatever, TCP, RDMA, NetBIOS, whatever, doesn't matter. So running over QUIC is not a big deal. So then the question that came up, obviously, was, okay, we had this presentation yesterday about Stanford's HOMA, H-O-M-A. And here's the link to the presentation, right? Should we support that? Why not? We can do comparisons. It's not hard. It's not hard as long as there's a kernel socket available, as long as there's a kernel driver. But what has hurt us? Unlike other operating systems, there is no kernel driver in Linux for QUIC. Windows has it, other OS have it, we don't. So we were kind of screwed. Well, the good news is these guys did a great job on it. Anyway, no head-of-line blocker, better congestion control, faster session establishment, reduced retransmissions, forward error correction, and a large percentage of internet traffic is already over QUIC. I've read something like 20 to 30%, right? Do you guys know the current numbers? If you look at internet traffic, a huge percent of it's already running over QUIC. So this is the future. So I don't know if somebody has the exact numbers, but there's an advantage to doing what the future is doing. So why don't we have it? Well, we have multiple user space drivers. Here's an example of Microsoft QUIC and user space. Google has a driver. But unlike Windows, we don't have a kernel driver. And many of these drivers wouldn't actually port well. So for example, we looked at Microsoft QUIC, and I'm pretty sure that I would have had to hide under the table to avoid getting stoned to death if I used that. Camel case, just 100 different things that the kernel requires you to do to make C more maintainable. The consistency of 30, 40 million lines of kernel code matters so much that they would utterly reject some of the user space drivers. It would require thousands of lines of changes because of cosmetic things. Okay. Also, this kernel coding style kind of matters so the automated tooling finds bugs easier. So a year ago, June 24th, Xin Long and a couple other Red Hat guys started a kernel project which is looking very promising. And a week ago, they resent it to the mailing list and started to get some good feedback again. Now, this week, we're doing additional testing on it. Obviously, today and yesterday, we're busy with presentations, but Paolo and I and others have been talking about this, right? And if you look at the mailing list, the NetDev mailing list and LinuxSys mailing list, you'll see this patch set. It's 5 to implement the QUIC protocol in Linux. It's gotten some feedback. They've revised a couple of the patches already as a result. It's fairly large. They also have a Git tree with the stuff broken down into smaller patches if you want. Now, okay, what's the number one feedback that I see that's an issue? Performance. The performance was worse than expected in their initial tests that some of the people did. So they had some theories. Was it lack of GSO support for QUIC? Was it the additional data copy on the transmission path? Or was it the extra encryption required for header protection in QUIC, or the longer header length? You know, these are theories about what might have caused the slower performance than expected. I also wonder, I'm not an expert in this thing, but there's a lot of tricks to interfacing with the hardware drivers for decryption and encryption. GCM does brilliantly. It's actually faster in SMB world to use encryption of the whole packet, seal, with SMB 311 encryption. It's actually faster significantly than signing the packet, because encrypting by default is able to use hardware offload, this GCM stuff. So I kind of wondered, well, maybe there's some hardware better interfacing, you know, in some of the drivers that they depend on. So anyway, the obvious answer people came back with was, oh, well, what about using IOU ring better? You know, one of the things that comes back as a reflex whenever a kernel person talks about a performance problem, they talk about, you know, folios and IOU ring. It's kind of a reflex answer, but I mean, maybe it is. So there may be little things that can do to improve this. Okay, so what about user space? You know, obviously we don't want just a kernel driver. We want a stable kernel driver that has advantages for user space. So METS, I didn't get a whole lot of discussion with them on this, but it sounds like METS, based on a quick conversation I had him, was able to do some simple tests with SMBD and QUIC, and you know, apparently simple stuff worked. But anyway, one of the things that excited me was yesterday, Ralph from the Samba team gave a presentation on the update on the Samba server and client and security tools. And Samba's 4 million lines of code, it's monstrous, huge stuff. But they mentioned they got about almost $1 million in German government funding. And one of the 5 projects they're going to work on over the next 5 years with the developers that this funds, one of the 5 is they have some very experienced developers that are going to be working on support of Samba server for running over QUIC. That also means, and they'll also be working on some RDMA, SMB direct things, and some metadata performance caching things. But the 5 features, 3 of them were extremely relevant to me, including this. So they're also looking at leveraging the same driver, partly because I think it might integrate better with their use case. So exposing it from, we'll see. It's an interesting thing. Obviously, there's other drivers they can use as well. But I was fascinated that they got significant funding in the last month, and one of the items that they've allocated for this is support for this, being able to use QUIC. Okay, so then the question I had, which was kind of obvious, you know, we were down in the test lab, and as you guys probably know, Windows supports SMB 311 over QUIC. So I was like, okay, how do I know that the server supports QUIC? So I was looking at, you know, some setup instructions for Windows, and there's good documentation, and Ned and others have given good presentations on this in past years at SDC, showing, you know, how QUIC works in Windows. But the obvious question I had is, okay, how do I tell that QUIC is enabled? And Zin actually quickly responded that, oh, that would make a nice test case we run, that kind of probes the target to see if that target supports QUIC. And so he was thinking of making a little test tool, you know, to do that, to make it easier from like netstat or telnet, right? Today you can telnet to a fake port to see if port 445 is open, right? What would you do for QUIC to do the equivalent to like tell if the target's even listening? And whether you call that from the mount helper or it's just some user fallback thing where they can type netstat something or other, he was up for the idea of writing a little tool. But then he just pointed me literally an hour or two before, earlier this afternoon, to this really interesting presentation I think you guys might find interesting. It analyzed QUIC deployments. So basically, it's a research paper that used cool tooling to try to figure out which targets support QUIC and to try to aggregate more objective data about endpoints that support QUIC. So anyway, it's an interesting research paper on that topic. I thought it might be worth following up. Okay, is QUIC just for Windows? Obviously not, right? Windows SMB 311, sure, it can use QUIC, fantastic. There have been great talks at SDC about that. But you know, downstairs, I think Visuality Systems is downstairs, right? Visuality supports it. So there's multiple services that already support SMB 311 over QUIC. So I'm kind of doing it as an interesting thing. as an experiment. We're doing it for Linux. Now, the three things that most interest me are the kernel client, the kernel server, and the user space server, and various tools, user space tools like SMB client. And it's useful for all kinds of different reasons. Sometimes it's easier to do certificates that are sort of machine level certificates. QUIC might make more sense for that. Sometimes because of port 445 blockage. You know, in Windows, it's fairly easy to configure. If you look at file shares, here's a slide from, you can see at the bottom, SMB over QUIC is not configured. So here is enable shares over QUIC, click learn more. So basically, if you want to click it, it's a simple page, go to file shares, configure. I mean, it's quite usable inside Windows, and we have a little bit of work before we make Linux that easy. Here's an example from a talk that Ned gave. I don't remember if it was here or at Samba XP, but it was maybe in the last year or so of Windows doing it. So basically, you net use, you get an error, network name not found. Okay, so get a certificate. So you have a PowerShell command to get a certificate, do a net use, works fine. So, I mean, literally, new certificate, tells you how to get the certificate, net use, done. I mean, how easy can you get? 2 lines to use QUIC. 1 to get the certificate, and then 1 to do the net use. And if you're curious about how it looks, the use of QUIC looks in the Windows, it's kind of similar to what we'd be talking about, that, you know, QUIC and these other, so it kind of gives you an idea of how, you know, the client opens this UNC name, it resolves using DNS, it attempts simultaneously connecting over both TCP and QUIC and sees which wins. So whichever connects first, it'll use. So if, for argument's sake, port 445 is blocked, it's going to use QUIC. Client will use whichever's connect first. Multi-channel will negotiate interface with the server and will select the most optimal protocols. So once you connect, it queries the interfaces and it dynamically sets up the number of connections properly. And then whether if your adapters support RSS, it'll set up 2 connections to the same adapter. And it automatically checks them, just like Linux does. It automatically checks every 10 minutes. And I think Mac does the same thing. And will automatically adjust how many network cards it's connected to, how many sockets it has. It's kind of a fun feature, so you get optimal performance. So that's what it looks like in Windows. And there's instructions, if you care about it, easy to follow instructions on how to set it up. So that's the Windows side. But what about the new kernel QUIC driver? So here's its Git tree. Git trees are very easy to find, lxin/QUIC. Inside, they have some excellent tests and excellent documentation. Okay, so quickly, obviously I've done some network development, but I'm not a QUIC developer. But I'm using it. What am I impressed with? Kernel style looks good. Remember we talked about how people would utterly reject most of the things that were proposed for QUIC in the kernel. There'd be no way they'd be accepted. Kernel style and code looks good. It was trivial to build. They have functional tests that are easy to run. It's 20.4K lines of code, about half of which is kernel code. That's the Git tree. And that was actually older. It's a little bit bigger now. Now, I just checked this week, like a couple days ago. The kernel piece in their patch set that they sent on the list a couple days ago is 12.5K lines of code. Can you wrap your head around 12,500 lines of code? Probably. The SMB driver is like 70 or 80. I think KSMBD is halfway, but the NFS server that Chuck deals with is way bigger than this. So it's something small enough to wrap your head around. They have an excellent set of functional tests. All of them passed when I tried. So I was curious, okay, are they really obsessive about testing? And then I looked at their change log. Okay, they updated a test last week. Okay, that's a good sign, right? When you're constantly testing and updating tests, that's good. Next thing, do the maintainers ignore you or do they just kind of throw you out there? Well, at midnight, he responded to me, and 12 hours later, he responded to me, and 2 hours before my talk, he responded to me. He's been pretty responsive. Now, another thing that impressed me. What about TCP versus QUIC? TCP is not really a fair comparison. QUIC is encrypted. Well, what if you just dealt with, what if QUIC was unencrypted? Well, he sent me this morning. I realize this isn't like official, but he disabled some code and ran some kernel tests. I don't know. It's just one person's run. He asked if we could find out from other people if they also saw the same thing. Basically, do you see what he saw, which was basically using QUIC was faster than TCP if you turn off encryption? Okay, I mean, it's just one data point, but it was, I was asking him that this morning, and he's like, yeah, I think so. Now, why do I care? It's like, I mean, if it's better performance, why wouldn't we use it? Now, if HOMA turns out to be better, then that, great. But one of the things I thought was fascinating was when we compare TCP with HOMA and say, or QUIC with HOMA and say, oh, QUIC is only for the wide area networks. Well, I mean, turn off encryption. If you trust the endpoints, and you're in an HPC world, trust the endpoints, if QUIC is faster, I mean, if that's true, is HOMA faster than that? I don't know. But my point is that without encryption, you may find that this is really good for HPC workloads. I don't know. I mean, it's something kind of fun to explore. Okay, so how hard is it to build? Okay, so these are the patches that were sent last week. 2 things, IP QUIC, IP_QUIC, and IP_QUIC test. They're easy to find. They're in the net config thing. They're turned off by default, of course, as you'd expect. I turn them on, but you turn them off by default, as you'd expect, because it's experimental. And they also have the test drivers here. You can also download from the Git tree and run the tests and do things like that. Okay, is it hard to build? No. So here's an example from an earlier version, the 6.9 version. Here's the module alias. I didn't have any trouble with it. Okay, so these slides come from Xinlong. I really appreciate the work that these 3 maintainers have done. But here's 2 other, Tyler and Peng Tao, here, other people who have contributed to it. I just wanted to call out because this work has been very good. They talk about the background, what QUIC is. It's a UDP-based multiplex secure transport, handles connection migration, multi-streaming. It's secured, encrypted with TLS 1.3, but the transport is over UDP. It has better flow control, congestion control, parallelization. Here's the RFCs that relate to it, 8999 all the way to, so anyway, there's a set of RFCs. Who are the kernel consumers? Obviously, HTTP is the biggest, but what we're talking about is kernel things. So it could be NFS, certainly SMB. We have multiple SMB servers and clients that already support it. Linux doesn't. This is what we're trying to fix. It avoids stereo copies, offloading to NICs, similar to TLS and IPsec and how it offloads. Maybe not as ideal as what we do for GCM, but something we can dive into. It has fewer interoperability issues. There's a ton of user land QUIC implementations, and there are just too many of them. I think this will really stabilize the world. I mean, as you see, I get emails, and I'm sure Chuck does too, daily from automated stuff. The amount of attention focused on kernel code is invaluable. If you get this in kernel, the chances are that the guy who invented the computer virus will find stuff like he did for me in the last 6 months. It's kind of weird to get emails from the guy who invented the computer virus finding security problems. Okay, in kernel QUIC versus crypto offloading in userland. So net supports QUIC crypto, offloading encryption to QUIC. TLS 1.3 handshake is already in kernel lib. And you can see the net link interface for that is already in kernel net. And the long handshake packets are protected. The implementation. The general idea is user space has the sort of the handshake message creating and processing. So the non-performance sensitive stuff is in user space. The kernel basically creates this new socket type running over a UDP tunnel. There's no protocol number needed. You don't have to reserve anything. They explain why they don't use the ULP label. The kernel consumers use handshake netlink to call up to get the handshake. Here's a kind of a picture of the handshake architecture so you kind of understand how they did this. So you have your handshake send receive stuff. You have your KTLS utilities there. So it kind of gives you an idea of which pieces are in the kernel and which pieces are in user space and how the app interacts with that. So the user data architecture. And the previous slide was the handshake architecture. Handshake and user data architecture. So you can imagine, in our world, we'll have the send and receive message coming from SMB, maybe sometime from NFS, maybe some block drivers, maybe some other kernel consumers. But we also have the ability to do it from user space. Users from user space. Did you have a... Okay, I thought you had a question, sorry. The socket process. You can see the SK hash table, the con ID hash table. Now, on the left, we have the client side. You can see the initial connection, handshake, back and forth. It's accepted, then user data is sent. It gives you an idea of what the process looks like on the socket setting it up. I kind of wanted to have a Wireshark trace to show you, and I may be able to do that next time. I meant to do that. But it can be used from user space or kernel. So in user space, the client side socket, you pass IP proto QUIC. You bind to that, connect, do the quick client handshake, send message. That's an example of what the client sees. On the server side, you're listening on the socket, IP proto QUIC. You bind, you listen. You accept the connection, you do the quick server handshake, receive, close, close. It's a fairly simple example to code in user space, and I don't know for sure, but it sounded like Mets had no problem with doing this in kind of a quick test in Samba. Now in the kernel world, it's a little bit different. So sock create, so KSMBD example, for example, the kernel, sock create, kernel bind, kernel connect, send message. And the sock create's pretty simple. You're just passing IP proto QUIC in on the, sorry, that's the client side. On the server side, it looks pretty similar. You do a bind, listen, instead of connect. When the connect is done, you do an accept, and then the client's doing send message, the kernel is doing receive message in this example. But it's actually fairly simple to what we already do. So what I love about this is it's actually not that different. So it doesn't require huge change. It might in cases like NFS, I don't know, like Sun RPC may be different. But in the SMB world, this really doesn't change much. So I kind of like that. I hope the HOMA driver example doesn't change much either, but I have a feeling that's user space code. Do you know if that's user space or kernel? They have a kernel module? Okay. Okay, so what are the advanced APIs? So they have send message with the CMessage stream info that sets the stream ID and flag, and receive message to get the stream ID and flag. They have socket options for key update, for rekeying the socket. They have a migration socket option to migrate the connection. And they have a reset and stop sending to manage stream, as well as a stream open. They also have this sock-op session ticket for session resumption. And the notification events they have are for connection updates and stream updates. Now, all of this sounds confusing to many people. And I mean, obviously, one of the problems in Linux code is you grep the kernel and you're not going to see anything exactly like this. One of the things I loved about this is they have a pretty good man page in their GitHub tree. You can see GitHub, LXN, QUIC. But even better, they have examples. So in their tests, one of the advantages is that their tests actually have examples that we can borrow from, because we don't have the luxury of being able to do what we do for everything else, which is just grep the kernel code for something similar. And I really appreciate the effort that Zinn and others have done. So what's the next step? Better hardware crypto offloading. My theory, and realize that the email exchanges have been only going on for about a week on this revised patch set, but that my theory, and it's just a guess at this point, we need more data, is that the performance issues they were seeing were largely due to the crypto offloading, but I don't know that as a fact. Also, they need an internet draft for QUIC Sockets API. Well, guess what? I'm pretty sure I got an email this morning, and I ran out of time to add it to the slides, but I'm pretty sure that they just literally put a draft together. So I'll check that, but I'm pretty sure that it literally just happened. So that's great progress. So, quick summary that he gave us. Enables use for kernel consumers. That's essential. We can't say we're going to use this highly secure protocol. I know it's only available to half the use cases. You got to have it available for kernel and user space. Obviously, we can't use IPCs up calls constantly. We can't IPC up call to do QUIC and things like that, right? We have to have kernel drivers for that. What I love about it, it's an easy to understand socket API, but so does he, right? It listens, accepts, connects, send, receive, close. Easy to think about, very similar to what we're used to. It avoids copies from user to kernel via send file. We don't want to have to force data transfer back and forth that's unnecessary. And it's easy to cooperate in the long run with offloading to NICs. You don't need any configuration in user space, and you won't have interoperability issues implementing QUIC this way. So I kind of agree with the summary he gave here. So what's next? Improve the performance and complete this congestion control. And there's some testing data needed for this versus KTLS in GitHub. There's a README about that. One of the things he was also doing was collaborating with some guys at Broadcom to implement the offloading better for hardware NICs. I don't know where that sits right now, and one of the things I want to follow up with. But obviously, those who work with networking hardware are probably going to be very interested, just like I am as a consumer of this, in getting the offloading with the kernel driver to work well. And this RFC doc that I talked about for standardizing the socket APIs, I'll need to check my email, but I'm pretty sure I just got an email about that. Okay, now what about my pieces? I'm the kernel client maintainer, and the kernel server changes also go through me. Namjay maintains that. Now, the pieces that I have to change are small. I have a new socket type. You see it on slide 26. You see it on the earlier slide, right? I have to use this identification sequence to identify SMB over QUIC. So it's 73, 60, 62. So I have this ALPN thing. And if you look in the protocol specs, and the protocol specs are pretty well written for SMB. If you look in MSSMB section 410, there's already a discussion of, there's a context called a negotiate context that's ignored if the server doesn't understand it. But if it does, this negotiate context indicates sort of like the double encryption problem I talked about, whether or not we need to double encrypt. So this context is very easy. It only happens during negotiation setup, and it's extremely easy to parse. So it required trivial extensions to the protocol. So what's the next step? We keep following up with the network maintainers to see whether they're accepting it. Obviously the merge window is opened. Are they going to take the patch set? I know they've done revisions. It might be the 6, who knows? Could be the 6.13 kernel, could be the 6.12 kernel, who knows? But we're hoping sooner the better, because we want to be able to, it's experimental, but we desperately want this. It helps with security and it helps lots of things. But we want to continue testing this tree. Now it is on the mailing list, so it's possible it'll be Linux next soon. We want to add the code to transport.c to read and write over the new QUIC driver. And this transport capabilities thing, this is a fairly easy thing for Paolo and me to do, right? This transport capabilities context. I'm not too worried about finishing that off. That's probably 100 lines of code or something. It's not much. So what about user tooling? So one of the things that we talked about is like how to discover the server supports it. Maybe we use a tool that probes the server. Maybe our mount helper could do that, right? Like the tool that Zen forwarded, that thing I mentioned earlier in the slides. Maybe we could make it easier that way. Maybe we could make a mount option that forces use of QUIC rather than doing what Windows does and say whoever connects first wins. So if you absolutely want to use QUIC, no question, we could have a mount option that forces QUIC. Maybe that's a good idea. But we could also change our mount code like they did and sort of parallelize. We already have had discussions about parallelizing setting up of multiple channels rather than doing them serialized. But anyway, this is an interesting discussion about what's the easiest way to use it. Do we just default to it, like the Windows example? Do we force somebody in the short term to use it with a mount parm? And how do we handle certificate setup and exchange? I think I showed you that example of Windows, which was utterly genius. They had a PowerShell command, one-line command, that got the certificate, populated everything, set it up, done. One line. If we had a one-line bash command, maybe something in sysutils, that, or maybe something in their QUIC utils, that sets up the certificate, does all that stuff without any thinking, this is awesome. Windows made it very easy. You know, could we do some tooling in Samba? Is there something in Samba, or is it something this would be a separate QUIC thing? And we need to encourage code contributors. And one of the reasons I'm glad to be able to present it here, and I also mentioned at Samba XP, is even though I'm a user of this, I'm extremely interested, and I'll submit patches for this too, but there are so many people just at this event alone who could make this code better. And the 3 guys working on it so far have done a great job, but they would love help on this very, very exciting feature. And of course, most important, testing the heck out of it. I like their tests a lot, but their tests are very protocol level. As an application, we need to do it. Now, if you look in the QUIC GitHub tree I pointed to, there's a test subdirectory. And for our uses in SMB1, we could probably just do the standard XFS tests. We also have a set of reconnect tests that, actually, you wrote a lot of the reconnect tests, that handle weird network changes. I think basically all we'd have to do is have a subset of our tests that literally run every single one over a QUIC mount. We'll need to come up with some improved reconnect tests. Paolo had some in the DFS group to exercise weird reconnect paths. And we'll need to test various encryption options, but that's fairly easy. And we already have pretty good infrastructure. So, you know, here's an example of our build bot. We literally run this every day. And we're moving to also some other options. Like I think I mentioned before, Lisa. There's some Azure automation that actually Microsoft has a project to make it a little bit easier to do some automated testing. The build bot's a little bit of a pain. KDevOps is used by most of the community for file systems and block drivers now. But basically, we run a ton of automation using standard tests, FS tests, GitHub tests, or sorry, Git tests. But we also don't want to forget that they're running, and you can see this is a test run I did, and they have more tests now. But you can see, how many tests are these? They're huge. There are, anyway, it's a very, very large number of tests that they have already built in for functional testing at the protocol level, 192 functional tests. And I think it's more now, significantly more now. So as long as we're obsessive about testing, obviously at the test event downstairs, we have the opportunity to test against multiple servers, multiple clients. But I think that I'm very impressed with this so far. We're going to try to run these tests regularly as soon as we have support for QUIC in the kernel that we can use. But I guess kind of what I want to come back to is thinking back to graduate school, knowing that TCP was horrible 35 years ago. I just feel like somehow there's hope in the world, right? Like, is that fair? Like, 35 years later, we're finally moving to something, and it's not just this. Obviously, the HOMA talk is also interesting, right? The Stanford guys talked yesterday. But finally, we're addressing problems that were discussed for 35 or 40 years. And maybe someday we'll even move to IPv6. I don't know, we'll see. You know, there's hope. Anyway, were there questions that I could answer? I know we have maybe a couple minutes left. Okay, Brad? Yes. So the question was, Linux had user space support. So is this a rewrite of user space support? To make it worse than that, I think I may have touched on it briefly in a slide. Linux not only had user space support, it had multiple drivers, all with different issues, different problems, different advantages, different disadvantages. I think the most popular is probably the one that the browser uses, but that wouldn't have helped at all with the kernel. Microsoft, as I mentioned, had a kernel driver for QUIC, and as I understand it, they took the Microsoft kernel driver and made it available in user space for apps. And you can go find, I have in my presentation earlier, you can go clone that. And there's apparently in Azure, there's a lot of Linux applications that use the Microsoft QUIC driver in Linux, which is a port, I guess, of the Windows driver. But the problem with that is none of them work in the kernel, and none of them would be appropriate for the kernel. So, for about a year, these guys worked their tails off coming up with 10,000 lines of good code, 3 or 4 developers, but they're experienced developers. There's guys who maintain SCTP. They're very experienced networking guys, and looks good so far. I mean, obviously, the devil's in the details. 10,000 lines of code, there may be some things to look at, but I'm very excited about this because they did the sensible thing. They let user space do some of the complex tasks. 10 or 20,000 lines of code are in user space, things that aren't performance sensitive. It's only the performance sensitive paths in kernel. But yeah, Linux did not. It was very weird. It's kind of surreal when you think about it that the most important place to put the driver isn't available. I'm puzzled. And here we have some Microsoft developers, and some of the Yep. Yeah, exactly. So he made the point that in some cases the majority of traffic going over the internet is like Google browsers, right? And it's not just Google. There's also a surprising number of social media sites that default to QUIC as well. So it seems like the world is moving that way. And obviously in the Windows kernel, they've done a great job with QUIC. And they've made it available to multiple services in user space and kernel. And I was startled, like the Microsoft QUIC driver used on Linux has lots of kind of specialized applications that rely on it. So obviously there's private applications that are using QUIC as well. It's well thought of, I guess, and it's very popular. But it's just surreal that this is 2024 and we don't have a kernel driver. So I was very glad that there's good feedback on the mailing list. It's gotten out to NetDev. They've had about a year and a half or a year and 3 months working through this stuff. Promising. Questions? Go ahead. No, so in Windows, the QUIC, and Ned has mentioned this pretty well in some of his talks, and I think there was talks by maybe Vladimir or others in the past about the Windows QUIC support, maybe at previous conferences. But they listen on the same port, 443, so UDP 443, so you have multiple listeners. And I think I mentioned earlier there's an ALPN. Let's see. So this ALPN, you send this identification sequence number, and I'm guessing that it allows the target to realize where it goes. Obviously, got work to do to experiment with this, but it can tell the difference between things coming in for SMB connections and things coming in for other things. But yes, it's the exact same port, so it's not blocked. So the beauty of QUIC is you don't use port 445, you're using port 443, it's UDP, so it's not going to be blocked. And by the way, there's some really cool stuff. They showed this earlier. You can, Wireshark decodes it, so you can see, I think, pretty sure you can look at your SMB. I mean, I guess what's good is that like the network analysis tools work, a lot of the stuff work because there's enough guys who implement it already that it's fairly well understood. But what I love about it is it's not blocked, and it's kind of a well understood model for using. Very similar to sockets, nothing confusing, and same port. Yeah, I mean, so your network provider could be very mean, right? The network provider could go through and say, 443, I see 7360, 62. Okay, I need to have unencrypted, I shouldn't allow encrypted traffic over that. Yeah, exactly. I mean, they could say the S is for Steve, M is my middle name, Michael. I don't know where the B came from. By the way, it is funny because at these conferences you meet the greatest people. So SMB and NFS were invented in the same year. Anybody know that year? 1984, the same year that George Orwell wrote in his book, 1984. I don't know if that's why, but anyway, 1984, NFS, SMB were born. We got a chance at one of these conferences to meet the inventor, Dr. Barry Feigenbaum. But imagine you were a young PhD graduate. You had just finished your PhD and you were stuck having to come up with a network, some protocol so you could pull files off PCs. Okay? SMB. So it's gone through many, many iterations, and it's shrunk down from hundreds of verbs down to a very compact, easy to understand set. It's a cool protocol. But I do find it interesting that if people made the mistake of blocking this, they'd probably be sending unencrypted traffic over the internet, doing something highly insecure. That's kind of what worries me, is that, in our world, we're used to military-grade encryption, strong authentication, man-in-the-middle attack protection, wonderful support for rich ACLs. All of this works great over the wire to dozens of different types of servers. Blocking it means you're doing something really dumb, sending your stuff via an email, sharing your presentations via some insecure app you don't trust, rather than being able to just mount your local disk. Okay, so we're reaching the end of time. Last question. So that's a good question. So let's see. Wasn't it this one? Forward error correction. Oh, yeah. So I should look up the technical definition of forward error correction. Does anybody have a good technical description of that? Obviously, the reduced retransmissions we know about, right? We know that QUIC makes it less likely to, to have to do these extra retransmissions. We understand about the head-of-line blocking. But I'm wondering if anybody has a good technical description of what he had asked about. What exactly is forward error correction? Anybody remember? I mean, that could be it. So the idea of basically buffering ahead of time, sending some additional redundant data, it could be that. But let's look at that, because that's a good point. It also, I think I mentioned this to you before, there's an incredibly good README that they include the documentation stuff. So it has a lot of this kind of information already in the documentation directory, in their merge set, and also in their GitHub tree that answers some of these questions more accurately than I might. I don't want to accidentally answer that wrong. Okay, any last minute questions? Otherwise, we let him get back to the next presentation. Anyway, thank you guys very much for your time, and we would love feedback on this. And as I mentioned, the maintainers have been extremely cooperative and helpful, and obviously there's mailing list discussion you can look at on NetDev. Thank you.